I have 144p squared minus 4 squared f squared. Again, another trick question because this one already has a power of 2. Leave the 4 alone. This is a square, this is a square. This one needs to have a power of 2. 144 is really 12 squared. And then I just bring down the p squared minus the 4 squared f squared. Now everybody is a power of 2, so I can use the difference of squares. So again, identify without the powers of 2. This is 12p minus 4f. And over here, the second set of parentheses will be 12p plus 4f. At this point in time, I'm not going to talk about factoring out a GCF just yet. I want us to get used to the pattern of the difference of squares. Normally I would say, yeah, let's take out a GCF. But right now, I just want us to get this far. If you understand how I got here, then good, that's where we want to be. I'll deal with a GCF like this one a little bit later on. All right, in this part, they want you to factor out the GCF onto this. Not so bad. All right, now understand what section you're in. This is a difference of squares. 18 is not a square, but it does have a square inside there somehow. Same thing goes with 50. 50 is not a square, but something inside of it is. Let's talk about this. 18 and 50 are both even. Because they are both even, that's interesting. So let's start out with that. If they're both even, they are divisible by 2. In other words, I'm going to factor out the 2, and I am left with 9n squared minus 25. 2 times 9 is 18. 2 times 25 is 50. I took this GCF out, this 2 out. Understand this 2 does not drop out. If you drop off this 2, you have a different problem altogether and not the original. So this 2 has to follow you through the rest of the problem when you factor this. Again, 9n squared minus 25 is different than 18n squared minus 50. Don't drop the 2. What we're going to do next is drop the 2, and from here I'm going to work this out. If you want to keep the brackets here, you can. 9 is really 3 squared times n squared minus 25 is 5 squared. Everybody's got a power of 2, and I have a minus sign. So I've got 2 times, and now I'm going to work this out on the inside. First set of parentheses, identify without the powers of 2, 3n minus 5. Second set of parentheses is the same thing, but with a plus sign. This is okay as far as an answer, but understand your book will not like that. Your book will say this is 2 times 3n minus 5 times 3n plus 5. It does not like the bracket because this is 2 times this, and so I don't need that added layer of brackets. The book will say this. It is okay to have this. Either one is fine. Let's do it again. 8 is not a square. 2 is definitely not a square. And these exponents, this is a 3. I should have a 2 or a 4 or a 6. This is a 3. That's a 2, that's great, but this is a 1. So what we're doing, one more time, remember, is factoring out as much as we can until everybody has a power of 2. Well, 8 is even, and 2 is even. I bet you 2 is a GCF that we can factor out. Since we know 2 is a GCF, let's look at this. This is 2 times 4 times r cubed. And again, you can rewrite the r cubed as r times r times r minus 2 times y squared times r. And notice what we've got is we have a GCF of 2 for the numbers, and there's at least one r that I can take out. What I am left with is what's not underlined. So we have 4r times r, which is r squared, minus y times y, which is y squared. 2r still follows through, because without that I am left with only 4r squared minus y squared, and not 8r cubed minus 2ry squared. I do need this to follow through with our problem. Using my 2r, 4 is a square, that's a 2 squared, r squared minus y squared. Now everybody's got a power of 2, that's awesome. What am I going to do next? I'm now going to use parentheses, and I'm going to do my difference of squares. I don't have to use the brackets, I can go straight to using parentheses. Just drop the 2r times, and I know that I'm going to form 2 sets of parentheses. Without the powers of 2, this is 2r minus y. Over here, same thing, but with a plus sign. So you don't need the brackets. Sometimes the brackets help people, sometimes they don't. But this is an example when you don't have to use them. So I wanted to show both cases. This is your final answer. All right, we have this new example. They always look worse than they really are. Please understand it. What do 45 and 20 have in common? The first thing I'm going to say is 5. Let's try the 5s. So we have 5 times 9 times mxyy minus 20 is 5 times 4 xxx. All right, so far so good. That's lovely. Underline what they have in common, which is a 5. As far as numbers go, that's it, because this is 3 times 3, this is 2 times 2. Next I'm going to deal with m. This has 1, this has 3, pick one of them. So I'm going to put out an m. This has an x. This also has an x. I'm going to pull out an x. These have y's. This one does not. So we are done with our GCF. I'm going to rewrite in parentheses what is not underlined. I have 9y to the power of 2, because this is y repeated twice, minus 4. M is repeated twice, and x is repeated twice. The 4 and the 9 do not have powers of 2. If you understand this from here on out, you can go ahead and go straight to the final answer. If you need the powers of 2 to help you out, that's why I'm here. That's what we're going to do. I'm going to do 3 squared y squared minus 2 squared m squared x squared. Now that everybody inside here has a power of 2, we're going to go ahead and, guess what? Do our parentheses. One's a minus, one's a plus. So you just have 3y minus 2mx, and you're going to have 3y plus 2mx. Again, without the powers of 2, same thing, but with a plus sign. The order of the variables does not matter. Also, one other thing that a lot of students ask me too is, does the order of the parentheses matter? Could you do 3y plus 2mx, 3y minus 2mx? That's perfectly fine as well. The order doesn't matter of the parentheses. What does matter is what comes first, what comes second, what comes first, what comes second. The plus or the minus sign does not matter.